Now we continue with mechanics.
We are done. We are done with conservation of linear momentum. We are done with that one. Now, but we are still under mechanics. Video number 3. Example 3. A particle P. I read the question. A particle P is projected vertically upwards from a point O with a speed of 28 meters per second. Find full column A. The greatest height H. The greatest height H above O reached by P. Is it clear?
Very, very clear.
Okay. No reflection.
Uh-huh.
The greatest height H above O reached by P. That is A. Then B. The total time before P returns to O. C. The total distance traveled by the particle. This is the question. Now, solution. We can, so that we can get the picture clear. So we can represent this distance, the distance traveled by this vertical line. So let this, between here and this point O, be H, which is the greatest height traveled. Now when we are moving up, acceleration due to gravity is negative. It's moving under the influence of gravity. So since it is going up, it is negative, meaning that A is minus G and minus 9.8 meters per second square. Let the vertical distance S be equal to H. Now, using those formulae that I gave you, that is equations for uniformly accelerated motion. One of these equations is this: V square equals U square minus 2GS. Okay, let me just say plus 2GS, where S is the distance here. So S is the same thing as this vertical distance from, which is H. So I can replace this S with H. V square is equal to U square plus 2 into minus G into H. Remember that this is minus G here, because we said it is as the body is moving upward, it is moving with negative acceleration, gravitational acceleration. V, the final velocity at the highest point rate is 0. So the value of V here is 0. So 0 square is equal to U square, which is the initial velocity given 28 square, plus 2 into minus 9.8 H. From calculation, 28 square is 784 minus 2 times minus 9.8 is minus 19.6. Minus 19.6 H. Now, solving for H, I have H equals 784 over 19.6 meter. So H is equals to 40 meter. That is the greatest height traveled. This answers question number A part. We are now to find the total time taken. That is the B part. The total time taken for the journey. So we can use this relationship, S equals UT. Again, this is one of the uniformly accelerated equations of motion. S is equal to UT, S equals UT plus half AT squared. Now we said H, this S is equal to the vertical height, which is represented by H. Hey, we replace this S with H. H equals UT plus half GT squared. H, since G, the particle was moving upward, and therefore the gravitational acceleration is negative because it's going against gravity. So it's UT plus half into minus G T squared. Plus minus is minus, so H equals UT minus half GT squared. And we say H is 40. We calculated H to be 40 in the A part. So 40 is equals to U is 28, initial velocity, T minus half times 9.8 which is G, T squared. 40 is equals to 2080 minus 4.9 T squared. So it has resulted into quadratic equation. It means we have 4 point. If you take minus 4.9 T squared across the sign, it becomes close. 4.9 T squared minus 2080 plus 40 is equals to 0. It's a quadratic equation, so we can use quadratic formula. You still remember your quadratic formula in Nigerian maths? Using the quadratic formula, we have T is equals to minus into minus 28 plus or minus the root of minus 28 squared minus 4 into 4.9 times 40 over 2 into 4.9. Remember that the quadratic formula we are talking about, the quadratic formula x is equals to minus b plus or minus the root of b squared minus 4ac over 2a. It's in your four-figure table. This formula is in your four-figure table, so you can lift it from the four-figure table. It is this formula that I have used here. Now, if you compare this equation with the standard form of a quadratic equation, ax squared plus bx plus c equals 0, the value of a here is 4.9. The value of b here is minus 28, which is this quantity, which is that b that you see here. C here is 40, if you compare. So, if this is A, this is B, this is C, plug it into this formula, then you get something like this. Now, when you simplify this, you have T equals 28 over 9.8, which is 2.857. Then the total time, that means to and fro now, for the particle to move up and from the highest position to go back to the original position O, you multiply by 2. So total time taken is this 2.857 times 2, which gives us 5.71 seconds. That is the total time taken. That is the total time taken. Then, for the C part, to calculate the total distance traveled, we had earlier calculated that the distance traveled from the original, the initial position O to the highest point is 40. That had earlier been calculated in the A part, meaning that H is 40. So we multiply that 40 by 2. That means the distance also traveled from the highest position to the initial position O. So 40 times 2, which is 80 meters. That is the total distance traveled by the particle. That will constitute a